by substitution and elimination. So first let's review what types of solutions can be expected when solving a system of linear equations. The first type of solution is that we have a unique solution, meaning that there's one ordered pair in which both lines are intersecting. That means I have a consistent, independent system. The other type of solution is that I have infinitely many, so I basically have one line on top of itself. Every single point is an intersection, so every single point is a solution to that system. So that implies that I have a consistent system since there is a solution, it's just that there's infinitely many of them, but the system is dependent because every single point is a solution to the system. Lastly, we could have no solution, so I have an inconsistent system. That happens when two lines are parallel to each other. When they're parallel, they're increasing or decreasing at the same rate of change, so there's never going to be any intersection between them. Let's start off by looking at the substitution method. So when we solve by substitution, we want to solve one of the equations for either x or y. You only have to solve one of them. You don't have to solve both, so don't make more work for yourself. We're going to use the expression we found in step 1 to replace the variable in the other equation. Now we're going to have one equation that has one variable in it, so we know how to solve those equations. We're going to go ahead and solve it. That gives us half of our answer. We then take that number, plug it back into one of the equations to find the other half. Once we have both variables that we're looking for, we're going to write it as an ordered pair, and then we can check our solution in both equations. So let's take a look at this system. We're going to solve it by substitution. We have negative 5x plus y equals negative 2, and negative 3x plus 6y is equal to negative 12. Again, we always want to make our lives easier, so we're going to look at both equations and pick the one that is easier to solve and pick the variable that's easier to solve. So looking at this top equation, we notice that the y is pretty easy to get isolated. All we have to do is add the 5x over to the other side. So that's what I'm going to do here. I have y is equal to 5x minus 2. I'm going to now take 5x minus 2 and plug that into the y of the bottom equation. So that's where the substitution is happening. So I have negative 3x plus 6 times 5x minus 2 is equal to negative 12. Now I have one equation with one variable. That we know how to solve. I'm going to distribute that 6 and then combine any like terms. Negative 3x plus 30x minus 12 is equal to negative 12. Negative 3x and 30x will give me a positive 27x minus 12 is equal to negative 12. Adding this 12 over will give me 27x is equal to 0. And then dividing the 27 on both sides, we know 0 divided by any number is always going to give me 0. So x is equal to 0. That's the first half of my answer. I now need to go back and find what y is in order to write my ordered pair. Since I have this rewritten top equation, it's easiest to just plug in the x here to find what y is. Y is equal to 5 times 0 minus 2, so y is equal to negative 2. That means the solution to this system of equations is 0, negative 2. The other algebraic method we can use is the elimination method. So when we're going to solve by elimination, we want to arrange the equations so that the like terms line up. That means the x's are under the x's, the y's are under the y's, the equal signs are under each other, and the constants are under each other. If that's not how your problem starts off, then we could just move things around using addition and subtraction so that they do all line up. As needed, we're going to multiply one or sometimes even both equations by a number so that we have opposite coefficients on one variable. So that's the elimination part. We're going to add the equations together and solve that resulting equation, which should be just a one-step, let's divide and get the variable isolated. That's kind of where I left off with substitution, right? We have one variable that we know, we need to go back and find the other. So we're going to find the second variable and then write our solution as an ordered pair. So in this problem, I'm going to solve it by elimination. I have 8x plus 14y equals 4, and negative 6x minus 7y is equal to negative 10. It doesn't matter which variable you eliminate, but just like substitution, we want to pick the easier one. So if I wanted to try to eliminate the x's, I have an 8 and a 6. The least common multiple between 8 and 6 is 24. So that means I would have to multiply both equations by a number to get that common 24. Could we do it? Yes, it's really not that big a deal. It's just a little bit more work than if I tried to eliminate, say, the y's. I have a 14y and a negative 7y. Well, the least common multiple between 14 and negative 7 is going to be 14. So all I have to do is multiply this bottom equation here by 2. But like I said, it really doesn't matter which variable you decide to eliminate. Just try to make the work easier for yourself. The less manipulating we have to do, the less places we have to make a mistake. So my top equation stays the same. 8x plus 14y is equal to 4. My bottom equation is going to be rewritten because we multiplied every part of it by 2. Negative 12x minus 14y is equal to negative 20. Now remember, we want opposite coefficients, so we want that plus 14 and that minus 14. Adding these vertically, I have 8 minus 12x, which gives me a negative 4x. These 14y's cancel. That was the whole point of this process. That's going to equal 4 minus 20, which is a negative 16. Dividing by negative 4 on each side, we have x is equal to positive 4. There's the first half of my answer. Now we need to go back, pick either equation that you want. Again, it really doesn't matter in order to find what the y value is. So I'm going to use the bottom equation just because the numbers are slightly smaller. Negative 6 times 4 minus 7y is equal to negative 10. Negative 6 times 4 is negative 24. I'm going to add the 24 over. Negative 7y is equal to positive 14. So y is equal to negative 2. That means my ordered pair solution is 4, negative 2.